Building a power supply. Hello everyone, welcome to this new course. In this course, we want to learn how to build a power supply. So let's get started. In this chapter, we're going to dive into power supplies, what they are and why they're important. If you wanna get stronger in electronics, being able to build a power supply is a must. But first, let's understand what is it. With very few exceptions, every electronic circuit needs some type of power supply. While some projects may use solar energy or less conventional sources like wind turbines, fuel cells, or nuclear reactors, most projects you'll build will draw power from one of two sources: batteries or wall outlets. In simple workshop circuits, most setups get their energy from batteries. This chapter explores how you can instead draw power from wall outlets. Wall outlets have a compelling advantage over batteries. They don't run out like batteries do, except in case of a power outage. However, wall outlets have an equally compelling disadvantage. They tether your project to a fixed location, often requiring long cables, limiting mobility. Most electronic circuits require relatively low DC voltages, typically between 3 and 12 volts. Achieving this voltage range with batteries is straightforward. Since each battery supplies around 1.5 volts, you can combine two or more batteries to reach the desired voltage. For example, if your circuit needs 6 volts, you can use 4 batteries in series. Powering a project from a wall outlet is slightly more challenging. First, the 120 volt supply or 220 volts supplied by the outlet is far higher than what your circuits need, so it must be stepped down to a more suitable level. Second, while electronic circuits usually require DC, wall outlets supply AC, necessitating the conversion of AC to DC. Third, circuits that directly handle 120 volt AC are inherently more dangerous than those operating at lower voltages because of the shock hazard. A circuit that converts 120 volts AC to lower voltage DC is called a power supply. In this course, you'll learn the basics of creating your own power supply to power your projects from a wall outlet instead of batteries, using a power adapter. Before showing you how to build your own power supply circuit, it's worth noting that you can likely purchase a pre-assembled power adapter that supplies the required voltage more easily than building one yourself. A power adapter is a standalone power supply circuit that plugs into a wall outlet and provides a specific level of AC or DC voltage as its output. As long as the adapter supplies the current voltage, you can use it instead of batteries for almost any circuit. When buying a power adapter, check its specifications to ensure compatibility. First, AC or DC. Not all power adapters supply DC. Some are designed for low voltage AC devices. Ensure the adapter outputs DC if that's what your circuit requires. Voltage level. Verify the output voltage. Some adapters have a switch to select between multiple output voltages. If using such an adapter, set the switch to the correct output level for your circuit. Current capacity. Most adapters specify a maximum current rating in milliamperes. Smaller adapters can handle a few hundred milliamperes, while larger ones may handle an ampere or more. Ensure your adapter meets the current requirements of your project. Polarity. Most modern adapters use barrier connectors, where the center pin is positive and the outer sleeve is negative. However, some adapters are wired in reverse. The adapter's polarity is usually printed on it along with the voltage and current specifications. Connector size. Power adapters come with a variety of connector sizes and styles. After buying an adapter, you might need to purchase a compatible jack for an electronic store to connect the adapter to your circuit. Some adapters include interchangeable plugs for different sizes. Pay attention to this tip. Using a power adapter instead of building your own power supply can make your project safer to build and use. That's because the potentially dangerous part, the section handling 120 volt AC, is fully contained within the pre-assembled adapter. However, as you'll soon learn, with power supplies, you often get what you pay for. Many inexpensive adapters convert AC to DC and step down the voltage, but fail to deliver clean or stable DC power. So even if you use an adapter, you might need to add circuits to improve the quality of the DC output. Understanding what a power supply does. If you want to add a power supply circuit to your project to convert 120 volt AC into DC suitable for your circuit, the design must provide at least 3 distinct functions. First, voltage conversion. Step down the 120 volt AC to the desired voltage level. 2. Rectification. Convert the step-down AC to DC. Note that the DC voltage produced by the rectifier is technically direct current, but it isn't steady. Instead, the rectifier produces pulsating DC, where the voltage oscillates with the 60 Hz AC input. Number 3. Filtering. Smooth out the voltage ripples created during rectification to produce a cleaner DC output. By mastering these concepts, you'll be able to design and build your own power supply circuits for more advanced and reliable electronic projects. So in the next section, I will explain more about these 3 parts of that I mentioned here. So if you like this video and you like this course, please give me a thumbs up. That would be awesome. And if you like this video, please like this video and subscribe this channel and share this video to your friends and who likes to learn electronics from our channel. So to the next video, please take care, see you soon, and bye bye.